In general, contemporary urbanity is located in low-lying areas and depends on terrain in higher areas to supply water of adequate quality, as well as prevent flooding in periods of excessive rainfall. In this context, nature-based solutions are of interest. With this in mind, to strengthen the resilience of ecosystems, a traditional water management system in Galicia is studied and described, which could well allow the design of new nature-based infrastructures. The presentation is organized into 4 parts. 1. Natural and local conditions. 2. The methodology employed to represent the water. 3. Traditional nature-based solutions. And 4. Some conclusions based on the study's findings. The terrain is undulating and the maximum elevation does not exceed 2,000 meters. The coastal mountains are small elevations of 600 to 700 meters. The coastal mountains are exposed to westerly winds originating out in the Atlantic. Not encountering any obstacle, these coastal mountains become water attractors. Annual average rainfall of 1,800 to 2,000 millimeters. A fundamental feature of Galicia's landscape is the rivers. Historically, Galicia is defined as the country of the 1,000 rivers. In reality, there are 21,000 continuous streams of water spread evenly throughout the territory. It is almost impossible to travel more than 1 kilometer in any direction without encountering a water current. This dense hydrological network results from high levels of rainfall combined with the impermeable nature of the rocks, granite and schist forming the substrate with fractured aquifers. Having been subjected to erosion and weathering, the surface layers of impermeable granite function as a sponge, absorbing a considerable volume of water which is effectively stored since it cannot drain away. The water retained in the winter and spring months drains away slowly during the dry summer season via numerous springs. This type of aquifer does not contribute greatly to the total water supply, but does retain water close to the surface throughout the dry season. There are many well-established settlements in Galicia. Over time, this has led to a unique pattern of development with more than 30,000 hamlets. More than half of all the settlements in Spain are to be found in Galicia. Here are Galicia's built-up areas located 100 meters below sea level, where 2/3 of the population already live, with the consequent depopulation of the rural interior, in an extended seaboard of more than 1,500 kilometers of generally low-lying, accessible, and specially sheltered in the interior by its rias. Thus it is very vulnerable to climate change consequences, as much the rise in sea level as this extended urbanization, which does not but only increase the chances of draining rivers and runoffs of high tides, as has already happened. The case is of the geography of the upper levels of a valley found in one of the coastal mountains. It is representative of many of the numerous small valleys comprising the dense hydrological network which precedes the urban areas on the valley floor and coastal areas. It's a north-south orientated valley parallel to the coastline. El Rosal Valley has the river Tamuche running into the river Minho. This flat terrain around where the Tamuche enters the Minho has favored recent urbanization. This area is precisely where the danger of flooding has been flagged up. Galicia's most striking feature is its very long history of human settlement, demonstrated by the astonishing range of toponyms that have been given to many locations of the territory. Those that refer to water are 15% of the total. A digital model of the terrain enables us to recognize each fold of the territory and represent the veins of water. Reading of small forms won't be possible with conventional cartography. From toponymy and fieldwork verification, it is possible to classify these water courses into continuous and discontinuous currents. From these natural conditions, a series of strategies have been implemented during this period of anthropization. These are examples of underground taming of floods for irrigation, facilitating refilling of aquifers due to increased water flows during the wet season. This process mitigates the effects of flooding downstream and also reduces the effects of drought by making subterranean water available. The subterranean aquifer is a buffer serving to overcome variations in the natural water supply. These techniques can be summarized as, firstly, techniques for dispersion of natural effluent flows, and of the copious runoffs of rushing water, maintaining and/or implementing an inverse arborescent network using levadas and irrigation channels, with retention and regulation tanks, causing the dispersion of excessive flows and minimizing water circulation speeds. Secondly, techniques of accumulation and storage of water in the higher zones of the coastal mountain ranges and communal baldios, avoiding uses in forests incompatible with its spongy edaphological properties. Finally, bypass techniques such as regos foreros prevent the flow of rough water through valuable areas in need of protection and divert it along alternative routes. Area of lameiros in the upper zones and area under irrigation. The winter irrigation refills the shallow phreatic alluvial layers, so water is available during times of scarcity in the summer period. Traditional water management allows the comprehensive resupply of aquifers, which makes water available during the dry season. A lack of this management increases river flow, exacerbating the problem of flooding already existing downstream, aggravated by increases in sea level. It would be better to avoid abandoning the high and medium zone traditional hamlet of the valleys and valinos, and thus reverse the depopulation of these areas and the concentration of their former inhabitants in the urban seaboard environments, and also to retain the previously constructed territorial elements that are still useful. These can be integrated into contemporaneity and implemented integrally with new networks and elements.